Hi guys, good afternoon. So in the last session, we were discussing about the HRP topology table, and we saw that the topology contains what? Successor and feasible successors. Successor is the best route. This is present in your routing table also and your topology table as well. Then feasible successor is there. So this is the second best route and it is available only in the topology table, right? And how can we check the topology table? By using the command show IP HRP topology. In the topology table, we will see the route states. So we have two route states, which is active and passive. Passive means the route is reachable and active means the route is not reachable. So in what case you are going to see the passive active state? If your successor or feasible successor is failing in that case. Okay. So here is an example. So here is an example of how entry in a topology table looks like. So here you have the state, okay, which is indicating that it's an active or passive route. Then here it will tell you FD, that is the feasible distance. That means from self, what is the distance to the destination? From self, what is the distance to the destination? That is what? Feasible distance. And here you see here, first of all, feasible distance, then we have the advertised distance or reported distance. So what is the reported distance? Reported distance is my neighbor, how much distance he is telling me. That means whatever the total distance is there from me, that is my feasible distance. And whatever my neighbor is telling me, that my neighbor is saying that, okay, from my place, the distance is this much. That is the reported distance. So you can say my self distance is FD and my neighbor's distance is what? RD. Clear? Okay. Then after we were going with the topology table example that, about the feasibility condition, that how the feasible successor will be there or not. That part we were discussing, but due to the gigabit interfaces, we were not able to get a feasible successor. So what I'll do now, I have uploaded the router. So we'll create a lab with the F, that means fast Ethernet interfaces, and then we'll do the practical. Okay. So what difference will be there in the lab? Two differences will be there. Number one, interface will be fast Ethernet. That is the first difference. Second difference, since the interface is fast Ethernet, the operating system version will be 12.x. That means there we will have to give the no auto summary command. Otherwise, the IGRP will summarize the routes automatically. From 15.x, the auto summary is by default disabled. Okay. So these two changes will be there. So let's go for it directly into the lab. Yes, sir.
Sorry, sir, by mistake.
Okay. Start the event. This is the lab. So I'll just change these routers. Okay. So one question I gave you as a task, right? Which interface? Exit interface or neighbor interface? Exit interface.
Exit.
Okay. So now, hmm? This time we are not moving the cable also still. Solving the particle, but 15.x, right? Okay, once I will verify the interface of this router. Look like fast Ethernet on, but only one interface. Operating system is fine. Can we change the number of interfaces? Now let's verify once more. Screen. This time we are not moving it still. Fine. Hmm? Right now. Yes, for now. Okay. So we have 0, 0, 1, 0, and 2, 0. Let's say that should be more than good. Because here the iOS version is 15.x, so we don't have to give the node assembly. Stop it. Okay. So we need 5 routers. R1, R2, R3, R4. This is R5. 0 by 0. Again. Hmm. Start all the nodes. 6, 7, 2, 5. Where is it? Let's take axis R1, R2, R3, R4, R5. So we have access to all the 5 routers. No. Hmm. Let's write down the configuration here. Visible? Text is visible? Okay. Hostname, R1. Interface, F0 by 0. F0 by 1. Sorry. This is F1 by 0. 13.1. Noted down. Then router EXRP1 network. Thirteen dot zero. This is for R2.
No auto
F050.
summary, sir.
Not required. This is iOS version 15.x.
Yes. Thank you.
In 12.x, we will require it. This will be 25.2. Wildcard not required because auto summary is by default disabled. So it is by default classless only. And then R3. So this will be 13.3. This will be 34.3. R4. So R4 is 34 and I think 45. Yes. 34.4. And this is 45.4. 34, 45. R5. 25 and 45. Loop back. Okay. All the configuration is done. Now let's check. First of all, R1. R2 configuration. Hmm? Right click. So placed in terminals like putty, mobax, you have to use right click. Okay, so we have two adjacencies here. Here also two adjacencies. Here also two. There also two. And here also two. Everything looks good. Let's go and check the routes now. To IP, yeah, exactly. Topology. So if we take a look again for 5.5.5.5. Okay, take a look for 5.5.5.5. What do we have? The FD is 158720 and the RD is 156160. So this time we will be able to manipulate a little bit. So let me keep it here so that we can have a proper visibility. Router 1K 12.2 तो मतलब तो डेटा मेरा आरटी वो है 1 मतलब यहाँ मेरे यहाँ से पहुँच कर इट्स द वैल्यू ऑफ wait a minute. This value here, this is what R2 has informed me that, okay, from R2, this is the distance. And this is my distance to R2 plus this distance. That means whatever R2 has told me, and from my place to R2's place, what is the distance? Okay. If you want to understand it with a non-technical example, everybody knows this place, right? No? Now let's say here you are in HSR. Okay. You are in HSR and one of your friend is there somewhere in between. This is your friend. Your friend tells you that, okay, from my place, let's say he is somewhere nearby airport. Okay. So this is you. This is friend. And this is destination. Okay. So now let's say you and your friend are planning to go here. So you will ask your friend that, okay, I want to go there. Your friend will say that from my place, this distance. From my place, Nandi Hills is, let's say, so your friend is going to tell you here. Your friend will give you this information that from my place, let's say, like this distance here. So say this distance is like, let's say 20 kilometers. Okay. So your friend will tell you that, okay, my distance to a Nandi Hills from my home is what? 20 kilometers. Okay. And then you will say that, okay, fine. From my place, airport is how long? Let's say 45 kilometers. Okay. So that means when you will calculate total distance, so you will say, okay, from my place to my friend's place, the distance is how much? 45 kilometers. And my friend is telling me that from his place, Nandi Hills is how long? How far? 20 kilometers. So that means now you can easily calculate, right, this total distance. 65 kilometers. This is the, what you see here. This is the AD or RD, advertised distance or reported distance. And this total distance that you're calculating, this one, 65 kilometers. This is your FD. Now clear? That your total distance is what? FD, and whatever your friend is telling you, that is RD. So how do you calculate FD? Whatever your neighbor is telling you, plus your distance to the neighbor. This is how you calculate. Understood? Now FD, RD clear? Okay. So this is the case with no successor. Nothing. Why? Because feasibility condition is not true. We are going where? 12.2. Now I'll go and shut down this interface F0 by 0 so we can understand what is the distance on the other side. So I'll go on R1. Interface F0 by 0 and I'll say shut down. Do show IP EIGRP. Follow. Now I can see. Yes or no? What do I see here? This is when I'm going via the second path. 13.3. Okay. Now I need to make it successor. What is the feasibility condition? Feasibility condition says that 5.5. Yes, for 5.5. So what is the feasibility condition? That the reported distance of a route should be less than current FD. That means RD of the route should be less than FD. So that means this. Wait a minute. This is F1 by 0. How come this is less? It should be more, right? Delay is more. Okay. I think I have taken the wrong route. Correct. That's why I was confused like why. Again, see what is the case. This is equal, the RD is equal to FD. Now we need to reduce it. What we need to do? We need to reduce it. So how will we reduce it? Again, we can look at the formula. So this time we have two options again, bandwidth or delay. So we can now play with delay because this is cumulative delay, total delay that is considered here. Okay. So if we look at the fast Ethernet interface, what is the delay? 100. The delay is by default 100. If we take a look, if I say do show interface F0 by 0. So if we take a look at the delay this time, 100 microseconds, right? Now we need to reduce it. But first we will make a calculation, right? This is the bandwidth, 10 raised to power 5. So put it in the formula, 10 raised to power 5. So according to formula, we will have what? 10 raised to power 7 divided by 10 raised to power 5. Then plus total delay. Now if you look at the total delay, look at it here. Total delay is what? 100 plus 100 plus 100. Plus for loop back, it is 5,000. That means 5,300. That means the value will be 530. So cumulative delay, if we say, so your total delay will be, you will say 100. Okay, if I mention it like this, for 3 routers, 100 plus 100 plus 100. And for the loop back interface, it will be 5,000. Okay. And then divide by 10. So if we make these calculations, so we will have 100 plus this will be 5,300. 5,300 divide by 10. right? And this value here, okay? Don't forget this thing, that this will multiply with 256. Okay. This whole thing will multiply with 256. Now calculate this thing. 280, right? Same value. So this is equals to, so you can say 100 plus 530 multiply 256, which is equals to 161280. Correct? Okay. Now from here we came to know the calculation. Now if somehow I reduce the delay by 10, if I reduce the delay by 10, that means this value will become 529. Okay. So do one thing, multiply 629. Okay. 629 by 256. So still not sufficient. Okay, make it, let's say, 621. 158976. Okay. Still it will be higher. So we need to further reduce the delay. So let's say I'll make it 10 and 10, 120. Okay, multiply 512. That will be right. So that means what I'll do, I'll make this one as 10, this one as 10. Instead of 100 and 100, I'll make it 10 and 10. So when I'll make it 10 and 10, what will happen? 20, 120. So this will become 5120. And when 5120 will be multiplied by 10, so this will be 512 only. Or not 512, this will become 612 because we have this 100 also. Yes. No, 612. 612, right? Multiply 612 by 256. Is it 156672, right? And then it will work. That should work for us. So we'll go and change two delays, okay? We'll change two delays to 10. From 100, we'll make it 10. So that means two delays I'll use. Let's say, for example, I can use F0, F1 by 0 and F1 by 0, R1 and R3. Let's try. Interface F1 by 0. I'll say delay 1. And same thing here, R3. Interface F1 by 0, delay 1. Now let's take a look. Do show IP IGRP topology. Okay, that interface is down, right? So interface F0 by 0. And I'll say okay. Now we see here Correct? So right now what is happening that this has become our successor and this became our feasible successor. Why? Because here our metric is more. Okay. This is clear. We reduce the value so much. We just need to. This FD should be less than current RD. Okay, so instead of changing here, I need to change here. We want that this one should be the successor only. Interface G1/0. Sorry. Yeah. But we got the feasible successor right now, okay? That is not a big deal, but here I have delay 1. So now let me check. Do show IP, EIGRP topology. Okay, now it's correct. So you can see that this is my successor. This is my FD. 156672. Still not properly updated. Strange, right? Nobody's having this FD. Let's wait for 15 seconds. Now, going back to default condition. How come is it saying FD is 156672? Let me do one thing. I'll go here, remove the phi network, and then add it again. Enable configuration terminal, router EIGRP1, no network, phi.phi.phi.0, network, phi.phi.phi.0. Okay, now it's coming correct. So our goal is that we have to make it less than this. Okay. FD should be less than RD. But if FD will become less than this, just a minute. This should not happen. EIGRP matrices. Update process, split horizon. FDRD. lowest bandwidth community delay, that is fine. Metric tuning. No, it's not about that. So this is the feasibility condition. It says if a non-successor route's RD is less than FD. Okay. Then the route is feasible successor. And here what we are saying. Yes. Okay. See here, the comparison we are doing is reverse. Okay. Feasibility condition RD of the route should be less than current FD. That means we just need to make sure that this 158720 gets less than this. So all we have, that means we cannot reduce the delay of here. We cannot reduce the delay of R1, but we can reduce the delay of R3 and R4. That's it. Only that is the change. So if I go on R3, let's go back to delay 1. If I configure the delay 1, let's see if it reduces. And we can see the delay has been reduced and we got a successor because the RD is less than current FD. The RD of the route is less than current FD. Understood? My RD is less than current FD. So I have a successor, right? I have a one successor and one feasible successor. Correct? Okay. So if you want more detail, I think you can check more detail also about a particular network. Okay, so like I can give 5.5.5.0 /24. Now you can see I have one route. Okay, I have one route which is 12.2 and another route which is 13.3. And you can see that how many successors I have? Only one. And the FD is this one. Okay, and this is what? This is a feasible successor. This is clear? Okay. Now, next thing we need to understand here is about variance. Next thing we need to understand here is about variance. So let's take a look that what is this variance concept. So after changing delay on R3 interface F1/0, we got this thing. Okay. Only on R3 one. Because we were focusing earlier on FD, changing FD. That's why it was getting complicated. Okay. So take a look. We know that AIGRP can also perform unequal post load balancing. AIGRP can also perform unequal post load balancing. Okay. EIGRP uses a variance multiplier to add feasible successor routes to the routing table. Okay, and what is the by default variance multiplier? Variance equals to 1. The default variance is what? 1. Now take a look here. See here. The variance is multiplied by the current FD. Okay. And any feasible successor route whose calculated metric is less than or equal to the product of variance and FD. Multiplication of variance and FD are added to the IP routing table, assuming that maximum path settings are allows more routes. That means in EIGRP, maximum path setting is there, that how many paths you want to use for load balancing. Routes that are neither successor nor feasible successor, they can never be added to the IP routing table regardless of the variance setting. This is clear. So it doesn't matter that what is their metric, what is the variance. If a route is not successor, not feasible successor, they will never be added to the routing table. Okay. Okay, note it down. In the graphical form also, I will show you once. Okay. Configuration, metric calculation. About the variance, here also there is something given. Just that diagram, I'll take it from here. White magnetic common key values. There it is. And this is how you can tell it in short. Okay, that means we will write down these points and then this parameter, that's it. Sorry? I know that they are remaining. I remember it. In short. in your topology table, you have more than one route, that is a successor and a feasible successor. Now, by default, only your successor is added to the routing table. So EIGRP will forward the traffic using one path only. But if you want that, okay, I have multiple routes, so I want to forward the traffic through all the routes. So in that case, you can use the variance. So when you multiply your current FD, that means your best metric with the variance. So whatever the value will come, if any route is having their distance less than the FD multiplied by variance, in that case, that route will be added to the routing tree. This is clear. This is how you calculate variance. This is the variance calculation formula. Feasible successor FD divided by successor FD. Okay. That is how you calculate the variance. So you can say FD of feasible successor divided by FD of successor. This is how you get the variance. If the value is there in the points, like 1.1 or 1.2, something like this, or 2.1, you just jump to the next number. Okay, you take a modulus and jump to the next number. That means if it is 1.1, I will multiply with 2, not 1. Because if 1.1 is the value, that means if you will multiply with 1, again the metric will come less. You want it that, okay, that feasible successor should be included. Okay. So in our case, if I do it, so try to multiply 158976 divided by 158720. 158976 divided by 158720. So clearly here, from here, we can see 1 point something value will be there, 1.1 or 2 or 3, 1.001, right? So again, we will jump with 2, because if I will multiply with 1, that will remain as it is, default. So I will jump to variance 2. This is clear. Online people getting it?
Yes, sir.
Okay. So here, what will be the variance value for us? It will be 2. Okay. So let's go here. Right now, if I check in my routing table, okay, although you can see I have two routes, one via 12.2 and another one via 13.3. So if I go and check, do show IP route and EIGRP. So you can see for 5.5, I am going only via 12.2. Okay. So if you want that, okay, what should be included? Wherein, I mean, feasible successor should also be included. In that case, we will go with router EIGRP1, configure variance, and variance value we can configure from 1 to 120. So let's say I'll configure it. As soon as I'll configure with 2, if I check do show IP route, you will see now I have two paths for the 5.5, one via 13.3, another one via 12.2. And you can see they are not even having the same metric. But if two paths are there in my routing table, my router will start doing the load balancing. This is clear. Now here you can also note down this thing. When the routes have been added to the routing table, the router supports a couple of methods for how to do load balance across the routes. So the router can load balance the traffic proportionally with the metric, meaning that lower metric route will send more packets. Alternatively, the router can send all traffic over the lowest metric route, with the other route just being in the routing table for faster convergence in case of best route fails. These are the two possibilities. So what you will say that one of the load balancing can happen proportionally, which means lower metric route will send all the packets. This is the first possible way. Another one, the router can send all the traffic to the lower metric. with the other route just being in the routing table for faster convergence. Okay, so this one also we can mention that how the load balancing will happen. See, this can be happening automatically. These are the ways of load balancing. The first possibility is that through lower metric, more packets will be sent, and through higher metric, less number of packets will be sent. Another way that all the traffic going through the lower metric only. But in case lower fails, then immediately that route will start. Okay. Online people clear?
Yes.
Yes. I think you're asking my question back to me. Hmm? You're asking my question back to me only. Tell me. I think I have discussed if you know this thing. That means I have discussed in the classroom itself. So tell me, load balancing is good or bad? Hmm? Yes. Good or bad? Hmm? Load balancing is good or bad? Online people? Nobody is responding. Have I not discussed in the class? I think in static routing, I have discussed this thing. We can have two routes with the same metric. Yeah. Router will start doing load balancing. Then I have asked this question. It's good or bad? Hmm? Tell me. Load balancing is good or bad? Let's see if you remember it. Hmm. Well, thank you for reminding. Multiple routes in the routing table with the same matrix, same AD value, everything same. Bad. Is it? Why? So if you have more than one route, that means what? If one of the route is down, second route is there to forward the traffic. So good or bad? Hmm?
It's
Hmm.
good, sir. It's good,
UDP, it's
but
good.
yeah, but when lots of links were down, it's critical to handle.
UDP, it's bad. TCP, it's bad. Huh? For TCP traffic, load balancing is good because you have retransmissions in TCP. Even if something fails, can be retransmitted. But with UDP, load balancing is not good because if your traffic is going through a different path and there is more congestion, that traffic you can forget. Retransmissions are not there. And second thing, if delay is there, so sequencing method is not there. The data cannot be coming up in a proper sequence. So sometimes in the bad weathers, we see, how the TV news looks like. Sometimes you get it, sometimes you don't get it. Sometimes you have voice but no video, sometimes only video but no voice, right? Those kind of things. Because sequencing is not there, then after retransmission facility is not there. So with UDP, load balancing is that, not for TCP. Okay, got the answer? Now, next thing is about AIGRP authentication. Now, what is authentication? Authentication. What do you understand with authentication?
Verification of the user.
User is valid or not? We are talking about AIGRP authentication. Note it down. AIGRP authentication is a way of creating neighborship and exchanging routes securely. Okay, by default, it sends on multicast address. Anybody coming on that multicast address with the same parameters will become enabled. But if I want that, okay, I want to do it securely, I want to secure this mechanism, then we can use authentication. So you can see that you can say that an AIGRP router will form a neighbor relationship and exchange routes with a neighbor router or with another router only if they have the matching neighborship criteria and they have the same authentication method and key configured. Okay. If the authentication key is same, if the authentication method is same, if the neighborship criteria are matching, then only they will exchange the routes. Otherwise, they will not exchange the routes. They will not even become the neighbor. Yeah. Now, if we talk about your classic EIGRP, okay, EIGRP have two modes, right? So one is named mode and one is classic EIGRP. The classic mode of EIGRP supports MD5 authentication, while the named mode EIGRP supports HMX authentication. Here, classic mode supports MD5 and named mode supports HMX. Clear? Now, how to configure authentication? So you will just create a keychain. So you will say keychain and you'll give a name to the keychain. Once you give the name to the keychain, you will give a key ID. So you will say key and key ID. Then you will give the key string. And in the key string, you will give the password. Once you have given the password, then we'll go to the interface. Interface name. Okay. Then you will say IP authentication. Okay. Keychain. Okay. Then we will mention the protocol name. That what is the protocol name? So protocol name is EIGRP. After EIGRP, you will say AS number. And then here you will give the keychain name. Clear? This is how we will do it. Then one more command we will use to mention the mode. So you will say IP authentication mode. Then for which protocol? EIGRP, the ASN number, and you will say MB. This is the configuration. Here. Same configuration should be there on both the routers. Same password, same method MD5. If you want to make them neighbors. Let's say right now, if I go and configure this thing on R1, so on whatever interface I will configure this, that interface will break the neighborship. Okay, see here. If I go here and let's say on R1 F0 by 0 interface, if I configure it. So first of all, create the keychain. I'll say keychain, let's say CCNP, EID 1. Then I'll say key string. And let's say password I want to give here, for example, EIGRP. This is clear. Now exit from here. Then I'll say interface F0 by 0. Okay. And before this, I want to show you, do show IP EIGRP neighbors. You can see that 12.2 is my neighbor right now. Okay, so interface F0 by 0. IP authentication. I want to use keychain. For which protocol? EIGRP, AS number is 1. And what is the keychain name? CCNP. Then I'll say IP authentication mode EIGRP1, and mode is what? MD5. And you see my neighborship is down. You can see my neighborship is down. And why down? Authentication mode changed. And here also you can see peer termination received. So now I will not have neighborship here. Why? Authentication is not matching. But if I go and configure the same authentication on the R2 F0 by 0 interface, then they will become the neighbors. So let's go and configure it. Enable configuration terminals, keychain CCNP, E1, key string. This password should be same. EIGRP. Interface F0 by 0. IP authentication. Keychain EIGRP1, and name is CCNP. Even still, it will not come up. Why? Because mode I have to change. So I have to say IP authentication mode EIGRP1, and you can see it supports only one type of authentication, MD5. Once I do this, the authentication will match and the neighborship is up. password, you can say kind of password. How you with EIGRP you don't log in. EIGRP is not a management protocol. This is for EIGRP to EIGRP communication only. That means whenever R1 and R2 are exchanging hello messages right now. So in the hello message, they are exchanging this authentication information also. Not encrypted. Okay. See here. In the hello message, they are having authentication as MD5. So only if this MD5 message digest value will match. That means if R1 and R2 will have the same authentication method configured, then only there will be communication. Otherwise, there will be no communication. This is clear that the mode is what? Authentication type is MD5 and the authentication or the password is same. If I go and change the password in the key string, see here. Let's say I'll go to the keychain. Key1, if I change the password, let's say instead of AHRP, let me change it to OSPF, let's say. Just the password I'm changing. If I'll change the password, you see what it gets. Okay, so that means my key string must match. If I configure back to correct, authentication will match and we'll have that adjacency. Clear? So if I don't, let's say for example, if I'm not having authentication right now, if I do not configure authentication, okay, and consider there's a switch in between. Maybe, right, I'm advertising the networks, right? So if I'm advertising the networks, so let's say I have one more network, for example. Let's say R3 have a network here, and that network is also advertised here in the AHRP. So AHRP will send hello message by default here also, this side also. Now here, this is my switch, but what if somebody else will connect a router here? What if somebody else will connect a router here? So what will happen? Those AHRP messages will come here as well. So this guy will see that, okay, what is the network being used? What is the network? Because he will also, this guy will also have a DHCP, and let's say he will get the same range IP address. Once he gets the same range IP address, what he can do? He can also configure AHRP on his router. He will get to know about the AS number and everything. Once he gets to know all these things, he can configure AHRP, he can make it neighbored. That's why we configure passive interface on this side, because we don't want any neighborship on this side. Passive interface will stop hello messages. Authentication is not stopping hello messages. That means even if, let's say, for example, here what is happening, that even if, let's say, passive interface is not configured, in that case, authentication will prevent. Hello messages will travel. So authentication will not allow this guy to connect. Let's say, for example, ATM machine and your debit card. Now, you know the PIN, right? You know the PIN and the ATM machine knows the PIN, or you can say bank server knows the PIN. So if you give your card to any random person, they will not be able to cash out anything. Why? Because they don't know the PIN. But what happens? You go there, you put in your card, you put in your PIN, you get the money. So that PIN is what? That PIN is for authenticating your card. Otherwise, bank has a card, bank has a ATM, why the money is not coming out? Because if directly by putting card, money will start coming out, then there's a problem for everybody. Same like there's a problem for your network. Clear? So passive interface stops your hello messages. Passive interface will stop what? Your hello messages. That EIGRP will stop sending hello messages. But authentication does what? even though your authentic hello messages are going, still I am sure that okay, only that person will be able to connect or will be able to form a neighborship with me who knows the password. That is an additional security. Clear? So passive interface combined with your authentication, now you can imagine it's a level of security, right? That is the case. Understood? And since your authentication method is MD5, that means we are using hash. So this password like EIGRP, this will not travel in plain text. So since your password will not travel in plain text, even if somebody is capturing these packets, they won't be able to know anything because the value is something like this. So if somebody will try to get this value also, let's say if I try to, there's no option to copy the value. And let's say if I go on internet, paste, and if I search it, I don't get any output. Is that clear? Understood? That is the case. So understood about the topology table, the route states active and passive. Okay. Then understood about variance and authentication. Now next session, we will start with EIGRP summarization. Next session, we will start with summarization. So both of the summarizations we will do, auto summarization also, manual summarization also. Okay. So for next session, our topics will be, note down the topics. You have weekend, so make sure you get prepared for them. Summarization. So one is auto summarization. Manual summarization. And then we will go with EIGRP leak mark. Okay. After leak map, we will go with EIGRP route filtering, EIGRP stub, and then we will go with your SIA query and reply. Then we at last we will go with EIGRP. VRF is a separate topic. Okay. So these things are pending in the EIGRP. So I think it will take 2 sessions. We have to speed up. We are going very slow. These are the topics remaining in your EIGRP, then your EIGRP is complete. How many sessions for EIGRP already? Because 3 weeks already done, right? Still we have 2 big protocols remaining, OSPF and BGP. This is the 5th lecture and 2 more, that means 7 lectures. Okay, no problem. So, any doubts? Online people? See, I'm not covering a large part every day. Why? Because so you can practice every day. Enough that you can practice every day. Otherwise, if I start summarization, then we'll have to complete all these things. Okay. So this is for the next session, and the next 2 next sessions we will complete this. 2 more sessions for the AR. Yes, you are able to see, right, that this is MD5. Password is EIGRP, correct? This is the hash value. So if with packet capture you will be able to see the password, then what is the point of doing the hashing? Otherwise, see, understand this thing. Let's say on the internet, your ISP is capturing everything. Now, it doesn't matter how many passwords you are setting up, then there will be no meaning of your VPN tunnels also. For security only, these are designed. And this is very small. Right now, this hash is very small. When it is HMAC SHA, you will see that this is this long. Okay. Okay, let me show you hashes. MD5 online. But someone knows if it is MD5, you can. How? Let's say, for example, always remember hashing is irreversible. If you have a hash value, you cannot reverse engineer it. Okay. Online, let's say MD5. Security. See, let's say here, if I have EIGRP, check the hash value. This is for MD5. This is for SHA-1. How? This is generating hash value. If you try to decode, let's say you see only generators are there. If you try anything like, MD5 decryptor. So first of all, there is no such thing. If any website is claiming that they will decrypt it, fake website. You're just wasting your time in there. Okay. Yeah, correct. Now let's say this is crack station. Hashes are irreversible. You cannot reverse engineer a hash value, like I said. If I'll give it. Now, this website is saying that, okay, this is a free password hash cracker, right? So how this is possible? I'll tell you once. See here. Now we got it. Why we got it? First thing, our password was very simple. So what these kind of websites have done, they have created something called as a Rambo table. Okay. There is something called as a Rambo table. Rambo table. They have created something called as Rambo table. So what is a Rambo table? A Rambo table is a file of pre-computed hashes. A Rambo table is a file of pre-computed hashes. That means they have noted down the common words like EIGRP, Cisco, 123. Then what they have done? They have already computed the hashes. That okay, for EIGRP, this will be the hash value. For Cisco, that will be the hash value. For 123, this is the hash value. So now whenever you're putting your word in there, they will do what? They will match with the hashes in the file. If it is a match, they will show you. If it is not a match, then they cannot show you. Like for example, let's try to generate a little bit secure hash. Okay. So what I'll do, I will use some sort of password generator. Okay. I'll use some sort of password generator. Let's say I'll use this from LastPass. Now, these are the utilities which are generating what? Very secure passwords. Okay. And let's say my password is what? Let's say I'll set it to 16 characters. Okay. And it will include uppercase, lowercase, number, and symbol. And if I refresh it, let's say this is my password now. This is the password I have set. So according to this password, what will be my hash value? This one. This will be my hash value. Copy this. Now let's give it to that crack station website. Let's see if it is able to crack it. Crack the hashes. Red. Not found. Why? because this is not some sort of decryption tool. This guy is matching with those files. This guy is matching with those files. So in the file, if there is an entry of this hash, it will say this is the password. And if there is no entry, this guy will say, no, this is not the password. This is how they are fooling people. Okay. Understood? Clear, guys, online people? And then, okay, in hashing, we have one more concept. In hashing, you have one more concept. When we talk about hash, so in hashing, we have a concept of salting. Now, what is salting? Let's say my password is EIGRP. So what my system will automatically do, before converting it into hash, my system will randomly add some value in between. And then after it will create a hash. So that means that hash will be not for EIGRP, that will be for this value. And this value is randomly generated by my system, and then the hash is converted. So you will never get the password. And even if two routers, or let's say two people are having the same password, two users are having the same password, for these two users, these values will be different. The random value will be different. So that means even though two users have the same password, they will never generate a same hash. So if one of the hash is correct, nobody will be get to know about the second hash. So many things are there in security. Okay. Don't think like, sir, this is easily crackable. Understood? Now clear? And because security is a problem, right? Slowly for why security is a myth? That also I can show you, but not for today. That for the some other session. This is clear.
Yes.
Now you got to know about hashes also. Hashes, salting. CCI security students must know this. Okay, in the interviews they can ask. Hashes, Rambo table, these kind of things you must know. If you are in the security, otherwise you don't have issue. Okay. All right, guys. Then this is it for the day. I'll see you guys on Monday. Have a great weekend.
Thank you.